Okay, at this point, we're going to take a little digression and talk about how to get these sequences. It turns out they're very easy to produce. So, how to get, where do good chip sequences come from? Well, one thing that you may remember from the first couple of weeks of class, we had this measure of correlation of random variables. So what we did was we multiplied the two random variables together, and actually it was a measure of correlation of random processes. We talked about the autocorrelation. So what we did was we took a random process, x of, actually it was a discrete time random process, x of k, and then we shifted it by a little bit, so x of k minus tau or something, and then we took the expected value of that. So what we saw was that if these were zero mean and independent random processes, then this could be equal to 0. Now, what's neat about this is that you don't have to do the autocorrelation of a process with itself. You can do the cross correlation between two sequences. So let's say between x and y. So again, if both x and y are independent random processes under any shift, this expectation should be equal to 0. They're independent zero mean random processes. So basically, this is the lesson we need to learn. If since this works under almost any shift, what we need is we need chip sequences that should mimic independent random processes. Why? Because this operation, multiplying all of these positions together, by multiplying all these positions together, what we want is then we sum over k. In any case, this operation mimics the dot product that takes place in the match filter. So we want this to be as close to 0 as possible. So we want these chip sequences to mimic this and come up with an answer as close to 0 as we can. So for that, we need a type of engineered sequence called a pseudo-noise sequence. So we need pseudo-noise sequences. So these are somewhat like if you had. They are similar to, but much simpler than, just random number generators. So, I mean, we generate pseudo-random numbers with computers all the time. The algorithms to do so are relatively complex, but it turns out we can get pseudo-noise binary sequences with nice properties with some very, very simple hardware. And what we need for that is a piece of hardware called a feedback shift register.